Episode of the Unplanned show, where we talk about how to deal with all the unplanned, exciting things that happen in the world of software and managing and maintaining digital infrastructure. With me today, I have a guest I'm super excited to have on, James Urquhart, who he and I worked together back at Pivotal and VMware. And so he is a distinguished engineer with VMware today, and the author of Flow Architectures, published by O'Reilly. So before we get into it with James, I'm just going to quickly give a heads up on upcoming episodes. Next week, we will have Mitra Goswami, who is PagerDuty's Senior Director of Data Science on. She just gave a talk last weekend at DataCon on generative AI. So we'll be catching up with her on that topic. And then the following week, August 28th, we'll have Donnie Burkholz on. And he and I were catching up earlier this month about kind of bridging ITIL and DevOps. So that's kind of an interesting topic. And then just a heads up, we will not have a show on September 4th due to the U.S. holiday for Labor Day. With that, James, welcome.
Well, thank you very much, Darmaine. I'm really excited to be on the show and talk with you today.
So just kind of like getting people up to speed, James and I obviously knew each other, but it was at GlueCon earlier this year, where you were giving a talk on flow architectures. And besides the Night at the Roxbury reference, which was deeply appreciated, it just overall sort of got a lot of wheels turning for me, just sitting in kind of like where I am now with PagerDuty and thinking about resilience. But let's sort of start at the beginning and just kind of level set with listeners in the audience around, what was the big aha moment for you when kind of like all the research that went into flow architectures, that sort of baseline for people to be thinking about? How should they be thinking about what is a flow architecture, and how does that connect to maybe things they're already doing today, but maybe some other things that they're not doing today?
That's a great question. So I have, 30-year career in distributed systems. And I think about halfway through it, maybe even a little bit less than that, I discovered some really good books on complex adaptive systems and sort of the way systems work and systems thinking. And so I have always kind of looked at the problem of distributed systems development, not as a mechanical problem, but as a systems problem. And increasingly, one of the aspects of that is when systems have a resource that must flow to the agents in the system, you have a sort of a natural evolution of the paths that those things take. And by the way, they're very consistent. There's a gentleman named Jeffrey West who works at the Santa Fe Institute who wrote a book called Scale. And in that book, he points out that these systems, large-scale adaptive systems that have flow, tend to evolve very much in the same way. So if you look at a tree, you get a trunk and limbs and branches and leaves. You look at the human body, you have sort of the core arteries and veins and sort of major blood vessels. And then that goes out to smaller and smaller blood vessels until you get to the capillaries. You look at cities, you have freeway systems that sort of carry the majority of the large-scale traffic that has to move around, but then that all kind of gets distributed out to major surface streets and then to neighborhoods. And the economy, there's a number, just the flow of money, right? There's a million examples of this where, basically the math of this generates these common patterns. And so as I'm thinking about data and the movement of data in distributed systems, I started thinking about, well, we've seen that pattern to a certain extent. We have large-scale data centers where the majority of data is stored. Now public clouds out there as well kind of fall into that category. So the movement of data, the generation of that data, storage of that data, and the movement of that data to where it's needed is sort of in a similar pattern today. You may break things out to the edge, but you're breaking out pieces to the edge in order to allow that edge location to distribute it further to terminals or whatever it may be. And anyway, all of that comes down to, one of the things that is not happening yet, but is increasingly important in the internet as a whole, is the real-time movement of data. is the flow of data from where it has the highest potential value to all of the places where it generates appropriate value for the organization that owns and generates the data, or the person, the individual, and that's a whole debate that can be had. But and to those that can provide some value around that data. And so there's a lot of things that happen over the course of extended periods of time. Extended periods of time is getting shorter and shorter, but we're still talking about, measured in days or many hours. And so I started, as I was thinking about that problem, to kind of wrap up the thought, I very much was like, well, what would break the flow of data? What would make the flow of data to those things of value easier? And I realized we already sort of have that within distributed systems within an organization. When you have event-driven or push-style data transportation. And so as I did some research into it, I discovered that there are no standards today for that. There's no standards for the interfaces or for the protocols that are general standards, but all of the influences necessary to push us in that direction are falling into place very quickly. So the commonality of the clouds and the services we're using in the clouds, the commonality of both the distribution of data through messaging and the consumption of that data or storage of that data, and the techniques used for that are becoming very well known and very kind of commoditized. So the idea that we could have standard interfaces comes in, and then we can talk more about it. But there's out of that aha moment, like, wow, we're going to move there. That just opened my mind up to a whole bunch of potentially positive and negative effects that come on with that.
Okay, so just to kind of recap a little bit, to just make sure I'm grokking this. Mm-hmm. This is this is a distributed systems problem fundamentally. Where anytime you have such a distributed system, you have to think about how anything, and in this case, data, is moving through it. And I love your example of just how these patterns exist throughout nature and society. Yes. By the way, if you've never played the game Mini Motorways, it's delightful and totally what I was picturing when you were describing, like how traffic systems, mirror these same patterns. But aside from, the pictures that pop up in my head, so within that, like, okay, now if those are the patterns, how do we realize value? I do want to double click on this notion of moving like high potential data so that its value is realized, whatever value it's going to, offer in the world. And is that something that, like, you thought about what does that mean? Like, what counts as high potential? Or like, is there a way to measure that or assess that to understand? Or is it just, it's a conceptual idea?
Well, I won't say measuring is easy, but if you followed at all Dave McCrory's work on data gravity over the years, so Dave introduced this concept of data gravity that says that applications and functionality will draw itself to data by something that looks very similar to the forms for gravity, the physical forms for gravity. Now, what is the thing that generates the gravity? And people often think, oh, it's the bulk of data, it's the amount of data, but it's not. It's the value of the data. It is how important that data is to some activity that all this functionality is related to, or some organization that is building numerous activities around that data. That's the thing that pulls things towards the data in terms of where things process and where the most security is applied, and all kinds of stuff are related to data gravity in some ways. So if you think about it in those terms, then you think about what happens when you're on a beach and you pour a bucket of water like 5 feet away from the edge of the lake or whatever it might be, right? And you pour that big bucket of water out and it starts to run towards the lake. And the gravity is pulling it down, but it has to work its way through obstacles and find a path to get to where it goes from the potential that it has at the beginning when it's dumped in that bucket to where it lands to have the most value, be part of the value proposition in that way. So a little bit of a stretch metaphor, but the core idea is that that you can think about generating value from data as being that sense of gravity. And in that situation, then high potential means the data is really useful for generating something of interest, something of use, but it's not in the right location.
Yeah.
Or it's not in the right form or whatever to do that. And then it's only generated value. It's only become valuable if it is then either has been processed or easily is processed by something that instantly creates something of value for its end user. And so that's the way I look at this is, there's tons of data being generated all over the place. There's IoT data, there's business data, there's consumer data. And, we have all kinds of weird stuff that goes on out there to make sure that data gets to something that's somewhere that's of value to somebody. But there's not a lot of control by the people or the owners, the generators of that data in terms of how that flows. And the argument that I'm making is that as the value of that data is realized, not only will some people open up the flow of data to other parties who can generate value from it, but also there will be demand to receive data in real time that today people don't look at so much in a real time sense. Good example of that is education data, right? If right now we look at, you completed a class, so the time frame that you need that data is very, very slow. You're not going to care if an hour after you complete the class, it doesn't say, hey, I've completed the class usually. But if we're tracking every action that you do that demonstrates experience in a field, and that decisions about who should we bring on this team to deal with this customer in this situation are in part determined by who has the best background to handle the problem and who has the time, then the real-time information about your schedule and about your background and all of that stuff becomes really important to your day-to-day life. And you're going to care about it being available much, much faster related to what you're doing. I think, to look at something that might be really relatable to your listeners, right? If you look at logs today, right? So where we've gone with logs is we've gone from, oh, hey, there are these things you can go look at if you're debugging a problem that has all this data that you can go text search or whatever and find what's going on, to increasingly watch what's going on in the logs in real time and make determinations about who to send that data and what to do with that data as quickly as you can based on what you see. Now, why is that important? Why spend all the money to figure out how to get logs into that more real-time sense of data transfer? Because we can generate tremendous value in preventative actions and in being able to resolve an issue in a minimal amount of time by having the signal as soon as we can possibly get it that there's some action that needs to be taken. I remember when I was at AWS and I would listen in on the operations calls there. And one of the principal engineers who sort of was helping to lead the call was asking one of the service teams, do we know, like scientifically or mathematically, is there a way that we can demonstrate that we're getting that signal the soonest we can possibly get that signal in order to be able to take an action on it? Mm-hmm. Right? Because the idea that they have is any downtime is hugely expensive. I mean, For AWS, it's usually expensive. For Amazon.com, it's immeasurably, insanely expensive, right? Like just milliseconds of delay in delivering a screen has millions of dollars of consequence. So they are absolutely very, very important, very focused on getting that signal sooner rather than later. And we all now are in the situation, and again, this is a natural systems thing, where we want a feedback loop that's very quick.
Yeah.
A feedback loop an operational feedback loop on the health of the system and both in terms of performance and availability, and then a developer feedback loop that's related to is the functionality functional, meeting the definitions of functional, but also B, when it's delivered, is it actually meeting the need and being consumed by the end user the way we expect them to consume it. And so those are the things that I say, high potential is, that data is in existence or can be in existence, can be captured, but just capturing it isn't enough. Getting it to where you can take the action on it the fastest is how you evolve the quickest towards the most value that you deliver.
Okay, you went really where I was going, which is like connecting this, which is the thought I sort of had when hearing you give this talk at GlueCon, was this seems really relevant to just the notion of resiliency for exactly what you described, right? The faster you can get that signal in and process it into something useful, the more valuable it is in terms of whatever system you're trying to keep resilient. But I think you're adding another kind of interesting element with just the idea of feedback loops, which comes back to also, just the pace of change that organizations are trying to sustain right now. And, this is a pace that's been kind of increasing over the last 10 years or so, we want to get better at change, right? And we're going to try to do it in smaller chunks, but really, really frequently. But you almost can't go faster than your slowest feedback loop.
Yeah, that's a good way to put it. And in fact, I'll throw one tiny thing out there. I think all the data, when it's generated, has value, right? The question is how fast does that value decay? And so if you catch it at the end of that decay loop, then it's still got value, but it's not as valuable as if you caught it early in that decay loop. Stock market data is always the example that's given really quickly, right? It's super, super, super valuable in the first few milliseconds, and then it has a decay loop from there. It's still really, really valuable, but the people who are catching it a minute or 15 minutes after that data was generated are not able to do the same things that the people who catch it in those first few milliseconds are able to do with it. Yeah. And so in the same way, I think, all of that data, this is the thing, is how much data is capturable out there that either you don't do anything at all to attempt to capture, or that you really are, capturing and throwing away, that apps that would potentially have some value for some particular use case. What we want to do is make it as easy as possible for you to evolve to the point where you realize that value is there and are able to build the systems that catch that value fast enough. But to your point about the slowest feedback loop, which I think super spot on and articulated in a way I really haven't heard it. The biggest issue that you have is, again, it's not valuable until you can take the appropriate action. And in the context that we're talking about right now, it's not valuable until you can take the appropriate action with it. And so how much value you receive in total off of the set of data that your system is producing is going to be in part dependent on how much stuff is waiting for that one important piece of data that puts everything together and results in the appropriate set of actions that have to be taken. And so you're exactly right. Like what you're trying to do is deal with constraints, just like with any process, just with anything else that moves through a series of steps. The flow of data to those things that take those actions and steps, you're trying to resolve as many of the constraints as you can in that system by the highest constraint at a time each time you move through it. At some point, you may get to the point where the cost of resolving this issue is higher than the value I'd get out from resolving it, and then you may sit with what you have for a while. But I would argue what standards do, and this is the key point, and one of the key points in the book, is what standards do is they mean that people build stuff around that standards, and you now automatically have things that already understand the standards, which lowers the cost of integration by orders of magnitude.
Yeah.
Right? I mean, you go from, I need a team of developers to sit and figure out how to hook A to B, to, okay, well, some APIs, but my developers still have to figure out how to write all the code that prepares the data in the correct form to send to the API or receive from the API, and how exactly to formulate the URL that's going to trigger the API, right? But ultimately, if you look at HTTP as a good example, right, there's a million libraries out there today that know how to take HTTP and either form the appropriate information to call a REST URL or whatever it may be, and to receive that data and parse it into the pieces and parts that you can use to either generate value whatever way it is, display it or consume it in an automated system or whatever it may be. And so, the Flow's kind of tagline is, in the same way that HTTP connected the world's information and created the World Wide Web, Flow standards, as they appear, are going to connect the world's activity and generate the worldwide flow. And I'm not tied to that term worldwide flow as like a brand or anything, right? Like, it's just the best term we could come up with in the course of writing the book. But the idea that we make it incredibly cheap to connect this flow of information, but maintain, and it's not going to happen until we can maintain provenance of the data, ownership of the data in some way, or at least value exchange for data. There's a bunch of problems, security, encryption, all those things, a bunch of problems that have to be solved, but we're on the way. And but when that happens, when people trust saying, you know what, we can point our materials processing prediction software at Walmart's product consumption data flow that we're paying them a small fee to consume, that aggregates data about what's being consumed, and we can then use another flow or another database to tell us what materials are involved in that, and then we can make some predictions based on that. Well, consumer consumption has been trending like this, and we can do things, right? But we can do that in a way that's more real time, meaning we don't have to do these big data runs and and sort of look at the data in arrears by a significant amount. We can actually track what's going on in a much more real time, and this is important in a number of areas. I've got some, certainly have some experience with when something went from being overnight to being real time, it changed the math and the economics of that activity. And so that's why, I think, connecting the world's activity will be increasingly important over time.
Yeah. A couple of thoughts. I think, there's definitely like an element of this. It seems like it's accelerated in the last few years with the pandemic, and that just pushing even more to be digitized. But I want to also come back to kind of this, all data is valuable when it's generated, but, then you've got to think about like the rate of decay and how it's not really valuable until you can take the appropriate action. One thing, obviously, generative AI is a really hot topic. So curious, like, how does generative AI fit into this notion, where obviously like things like the recency of the data can have a really big impact on what you could do from a generative AI perspective and how you train a model, whether
Right.
in context or having to do fine tuning. And there's, big implications from an engineering perspective,
Yeah.
cost perspective on those types of training approaches that you have to take. But when you think about the, what is that word? The half-life of the data
Uh-huh.
feeding in, just curious, like, how are you thinking about how generative AI and LLM architectures uh, fit with the sort of the flow architecture?
Yeah, it's the most interesting thing I've seen in the last probably 2 months is the data coming out about how ChatGPT is getting less accurate,
Mm.
right? And part of that is because yes, they retrain the model on a regular basis. The model picks up some bad habits, but it also has something to do with that the immediacy of the data that's being provided is something that's a challenge, is a huge challenge. Like, how do you go get the most immediate data on which to train the data, as opposed to okay, this was data we collected in mid 2022, it was expensive to collect, we're going to use this as the baseline for as long as we can. And not saying that that's what OpenAI is doing, but that's sort of I think the economics of the situation is it's really hard to keep it really up to date. So I would argue that one of the things that's going to come out of this is, how do we not only continuously generate up to date models, but how do we do that in a way that that is really low cost for us to engineer? Like, we don't have to do something custom for every source of data that we want to incorporate. We can do something basic. HTTP is great, except that HTTP, you got to go make the request for the data, and you got to follow the links. You got to do all of that. And so there's a whole bunch of processing that happens there. If you could generate a good baseline model and then have events coming in that are critical for from number of sources that are critical for your kind of baseline learning and your baseline understanding of the world. And by the way, you could say, hey, anybody who wants to connect data to us in some, here's the format that we're expecting, and here's how you can make that connection. And everybody goes, oh, okay, I already got the software to do that. I just need to point to your endpoint and maybe make sure it's in data format X. That suddenly changes the economics in a huge way. It changes the economics in the sense that now the system can be fed data by the community, by the economy itself. I always point out to people, the entire reason business software exists is to automate the economy, right? It's to automate the flow of money. That's why more and more of it exists, and to automate or drive the behavior that flows money. And so we kind of, that's kind of the key thing, is to say, okay, what if we can make it, instead of OpenAI or whoever it is goes out and has to figure out how to go get the data and how to source it and bring it in, and in a kind of a Google spider crawling model. What if it was, we've created some value here, people are using us as sort of a central thing. Here's how you can make sure that your data is part of the conversation and can be a part of what action takes place, and you can even protect it so that only certain people can get direct answers to certain questions or whatever. And all of this is this is speculative, but the key thing is if you can move the data, if you can have the system itself define how, from the people who have potential value, who want to generate value from that data, from those that are looking for data that would generate value for them, if you can make that evolution easier, you're going to create an environment that's much more broad. So I believe that the AI push is, in turn, over time, going to drive and even exacerbate the demand for standards around how data can flow. And in that situation, then flow architecture standards become more important.
Yeah, I think you're thinking like quite far out, to where you almost have like these exchanges of data between parties. And obviously, like, as folks, there's a lot of trust people have to build up, even within much more localized. But this notion of, even within an organization's, trying to just keep within their own kind of environment without having to think about how they're even attracting in more data. Just that idea of, how do we, to your original points, right, continuously update our models and do so in an economically feasible way.
Exactly.
Because I imagine people are going to be working on trying to solve that problem within their own four walls. And it'll be interesting to see, like, does that create kind of like a lot of different solutions to the problem that then have to reconverge into these standards once we really get to the point of actually, to do this even better, we have to start to move the data between entities, because right now just the privacy concerns around, well, what data are we training models on, seems really, really high. But I think, like,
But that gives some, I mean, you get some more flexibility in the sense of if the data provenance is sort of an agreement between those that are generating the data and those that are consuming the data, you actually create an opportunity where those that really want to be like highlighted or be part of the answer to a prompt have the opportunity to say, look, here, here's the current state of the world from where I sit, and please use it in whatever appropriate way. But you also have the opportunity for those that are like, look, I don't want my data to be consumed in the flow of this, to be able to in some ways sort of shut off the flow. And it's a total gray area, but I think that if the producer of the data has some say on whether or not they want to send the data to that consumer,
yeah,
that creates the economic engine to allow for a more trustworthy, less exploitive way for these models to be built over time. Silicon Valley's culture doesn't generally lean that way, but I think our overall culture, in the Western world at least, very much would like to see it be a more transactional basis for sort of saying yes, absolutely. And I think people don't understand, like, some of their data that they think they should keep private, what value it has if it's public in certain contexts. So, I talked about that education data, and there's other stuff too, but you don't want it to be misused. And so there's some opportunity to sort of control where data is flowing to a certain extent. It's, I don't know, but and there's so much left to be done here. I mean, all I can do is sort of lay out the model, for lack of a better term, the climate and the landscape that's sort of generating this need and this opportunity. But the actual way that it evolves depends on so many things that are, that the form that it takes will not be what I wrote in the book, probably. And I write that in the book several times. I'm like, this is my best guess.
yeah,
based on what we have today and what's out there today. We could do this if, these following things were kind of fall into place. But, we were talking about earlier about, sort of potential to value. Like, one area where we already do a lot of real-time stuff is telemetry. And we have standards now that have started to fall into place around operational data telemetry, open telemetry, and all the different processors of telemetry that now know how to speak in that standard, either generate or consume that data in that way. And you have messaging systems and other things that understand how to process that specific data. So Kafka and Rabbit and all those other things are more aware of that format. You have things like cloud events that can wrap open telemetry in another metadata format that can be used for other purposes. And so when I look at that, I'm sort of like, we don't have one standard, but we have a number of contextual standards that are working really, really well to demonstrate the potential solution. The question becomes, when does the economy as a whole, when do the businesses and the consumers and everybody as a whole realize how that mechanism would potentially be of value to them outside of the context of that specific protocol, right? So outside of the concept of telemetry, hey, if we had real-time operational data about our business operations that we could share with third parties that could help us resolve issues like logistics or whatever it may be, right? How would that make our lives easier and cheaper to operate, et cetera, et cetera. And so, yeah, so that's, I look at that, like, there are definite standards out there for flow in certain contexts. And the question becomes, I still believe a more general standard is quite possible.
Yeah. Well, I think that yeah, you have that's a great point where it's like, this isn't that within these contexts, right? Operational data being one, how the patterns are more mature. Maybe that's kind of like a fair way to say it. So, de facto standards have started to emerge, albeit in these smaller contexts. And so that's kind of what we're building off of as we encounter new contexts, things like LLMs, or encounter sort of new, um, well, I guess this would still just be a new context, right? When you sort of bridge out of a technical use case into a business use case of
Excuse me.
you want to have different data participate in that type of flow. So what do you think is kind of like, the any one person isn't going to determine a standard, but what are some things that you recommend for folks to kind of be thinking about or to be trying to put in place? I really like how you sort of break this down into almost like the sort of laws of nature, as the foundation, so that like as things evolve and change, to your point, it's like it's not going to look exactly like this, but we know it's going to look
Right.
something like this because we've seen this pattern before, and like these
Right.
fundamental forces of nature that will show up. So I think that's a really useful, kind of building blocks for thinking. But what else do you recommend to folks? Let's keep it kind of within, your sort of technical audiences. Like, how should they be thinking about flow architectures and sort of pushing those boundaries to sort of realize the value of data faster?
Yeah, so a lot of it happens already in certain ways, right? So there's a number of different, say, Apache projects and other open source projects that are about real-time data processing. What I would argue is, if you want to be, a part of a large system, as opposed to a fairly well-contained, well-scoped system where the data doesn't flow out of that very much, I would say you should be, stop trying to do peer-to-peer, right? Peer-to-peer at large scale has continuously failed, and it has continuously failed in large part because it's not a great natural flow architecture for a large scale system. Now, I'm being a little facetious in saying that. There's reasons to experiment with peer-to-peer, but don't be surprised when it doesn't work at scale. There's the major cloud providers, I talk to them all the time about, one of the things that they could help facilitate is, in fact, the consistent flow of events throughout their systems, and all of them have done a little bit of that in their own way. I mean, obviously, all the serverless stuff is very event driven. And so you have a lot of really cool things you can trigger off of changes in DynamoDB. You can trigger a Lambda that can go, put a message in a queue that can be picked up by an application running in a data center somewhere. And it's, all of that stuff is coming together fairly well. But I tell them, anything that you can do to make that and integration using that to things that are not already your cloud, anything you do along those lines is going to accelerate the ability of that organization to get data to where it's valuable faster, and that's going to generate demand. So I think right now it's hard to say that there's anything that is the standard that is, but there are some inside track things, right? I think for metadata, for the data that expresses what the event is, where it came from, and maybe where you can find a schema to read it if that's necessary. Cloud events, I think, is the clear inside track on that, and I would even say at this point in time they're more or less the winner, although not everybody has seen the value of having that metadata yet. Everybody that does say, hey, we need common metadata, for the most part, is saying cloud events at this point. Async API is a really promising element for the APIs to make all of this happen. I'm not convinced yet that it'll be the winner in the long term, only because you don't see it becoming the standard for the way you interact with, say, a messaging bus yet, right? They all still have their own APIs. They also have their own approaches. And I would argue that means that we're still looking for something. out there that says, hey, how can I consistently connect to a stream, regardless of who's producing it and what technology they're using? So there's still a lot, there's still a lot to be determined there. It could be that something like open telemetry gets adopted outside of its intended use. It could be that something that comes out of the Apache community ends up being a winner over what's coming out of CNCF, which is where cloud events is. It could be, a number. It could be that some government protocol that gets created becomes so important to business in order for it to be able to operate and interact with the government in the right way that it becomes the model that people follow. But I think that that you asked about the advice earlier. I think definitely cloud events. If you're putting metadata around any form of payload, then there's really no reason not to do cloud events at this point. But I would say that I'm really looking at right now, and sort of the evolution in the future of where we're going is more of these examples of flows that are going outside of a given company to another company. So FAA data, weather data, it's always kind of big examples. Walmart has required suppliers to provide them real-time data feeds of available inventory through a standard that they defined, or a protocol that they defined, right? So there's more and more of these examples that are happening, and where that data is really important. And I think at some point in time, the question becomes, when does it make less sense for everybody to have their own thing, and more sense it's just the cost becomes much better if we just have some standard libraries that everybody can point at each other and solve the problem. And I think we're still, when I wrote the book 3 years ago, 2.5 years ago, I said it was going to take 10 years. And I think 7.5 years sounds about right for, when it becomes a mainstream kind of thing. It's still on that kind of trajectory.
Okay. And, what you're describing, just as like in the kind of parting thoughts here, that idea of how like data starts to flow between organizations. I mean, again, this reminds me of how much that happens already on the operational data level with SaaS data. And, I'll just drop here for the comments for folks, a previous episode where we talked a lot about data ops that comes to mind. If you want to catch that replay, with James from the Snowflake team and Manaraj from PagerDuty's data engineering team, it emphasizes how, as we start to depend on these flows of data, in more cases, that sort of the data ops and all the data observability and resiliency practices are going to get more important. That's of course familiar territory here at PagerDuty with the Operations Cloud. James, I want to thank you for joining us. This has been really interesting, and I think just some great food for thought for folks just thinking about their own systems architecture, and as even in different use cases, they don't have to be a distributed systems designer to realize that probably some aspect of what they're working on is participating in the flow of data as things get more digitized, and that there's probably a lot more room for unblocking that flow of data and finding out how to realize the value of different data sources faster. So thank you. I think this is a lot of great just stuff to noodle on.
Yeah, I appreciate it. Thank you.
Yeah. Reminder, we've got Mitra Goswami next week and Donnie Burkholz on August 28th. And then we'll be taking a break on September 4th. James, thank you again, and hope everyone has an uneventful day.